Whenever there is data that is given, there are numerous ways to depict it, and one of the most simplest and the commonest way we would say is depicting the data through the tabular form, but this takes a lot of effort for a person who is actually reading it. So what we can do is we can simply do a graphical representation of the data. Graphical representation of the data can come in numerous ways. It could be by line graph, bar graph, pie graph, or sometimes we can have the map, and on the map itself we can represent the regions by various shades, gradients, lines or dots or whatsoever. So we would be discussing all those possible and feasible methods in this class. But before we begin, it's very important to understand that a visual understanding of something makes it much more simpler. A picture is better than 1,000 words. That's the most simple thing that we need to understand. So there are certain rules for drawing of the map. Now what are the rules for drawing of the map? The first rule is we have to select a right method. What is the method? Now this could be a line graph. If there are two or more values that are given, for example marks of boys and girls in the school, so we can use a multiple bar graph method, where we can have two simultaneous bar graph, one for boys and other depicting the girls, and therefore it's a multiple graph that could be a multiple bar graph that could be explained. Sometimes we can have the values in proportion, so pie graph is a good option. Sometimes we have values where the traffic flow can be explained. So let's say from Delhi to Gurgaon and from Delhi to Noida, what is the traffic flow? We can explain this by the thickness of the lines. So the commuting between Delhi to Gurgaon, let's say, is relatively less than Noida and Delhi. So the thickness of the line would vary in this case, and this is an example of flow chart. We would be discussing all of those as we move forward. So right now to understand is, the first rule is we need to understand a right method. Once we know the method, we have to understand a right scale. What is the scale under which we can reduce all the values? The next important element is any graph that you must draw should have a title, if required a subtitle which explains what exactly it is about. Then if it varies across years and we are drawing multiple values, then mentioning year is important. Let's say there are two line graph, one is for 2008 and the other shows 2010. Then mentioning the year becomes important. The next is legend. So legend basically says that the solid line represents the values for 2008, the dotted line represents the values for 2010, and that is the legend here. And then is the direction. What is the direction of the drawing curves? That is again important. The next is what we understand, the type of diagram. When we focus on types of diagrams, there are numerous types under which we can explain the various types of diagram. The first category that we can explain the diagrams is the category where we explain line graph. It could be in the form of bar graph. So we have examples of line graph, we have examples of bar graph, we have examples of pie diagram. So those are some of the common types of diagrams that are explained. Then besides that, we also have sometimes the flow charts that are there. We explain diagrams through thematic maps. When we talk about thematic maps, these are the maps of any geographical region, and on that geographical region you try to explain the development. So it could be either through a dot representation, a choropleth representation or a isopleth representation. We'll talk about all those in detail in separate section. But for now, what the idea is, under type of diagrams we can say there are one-dimensional, two-dimensional or three-dimensional diagram. One-dimensional diagrams are simple diagrams which are in the form of line graph. They could be in the form of bar graph, histograms. So those are common example of one-dimensional. Under two-dimensional, we usually have the pie diagrams that are explained, and under three-dimensional, cube and sphere are the common cases that are seen. But for now we would understand the very basic ones, and that is the line graph. Now for a line graph, let's say across the various years we have the profit values that are given. So we start plotting the profit values one by one. So let's say in 1998 the profit was 0.5. So we mark the profit at a region of 0.5. That was between 0 to 2. So under a line graph, what we first do is we take the x-axis and the y-axis. X-axis is the horizontal axis and y-axis is the vertical axis. On the vertical axis, we take the profit. On the horizontal axis, we take the year. So it is year versus profit graph that would be plotted. Now we see the values of profit ranges from somewhere between 0 to the highest value, which is around 14. So we would divide our graph in the values of 0 to 14. So we divide it in a gap of 2 to 2 each, and that would show us the vertical segregations. And for the year, we of course have 1998, 2002, so all the years in the gap of 2. But the interesting phenomena here is for 2012 we have one value which is negative. So what happens here is the graph goes below the 0 mark. Now if we talk about the gradients, in a xy coordinate we have plus plus, then here x would be minus but y would be plus. Here both would be minus, and here the x would be plus but the y would be minus. So what would happen is you would have plus minus gradients that would be seen, and here the profit would be in the lower gradient that would be seen. So we understand the line graph. So time series we usually see on a x-axis. Whenever we are plotting a line graph, we see a time series on a x-axis and quantity on a y-axis. So that is the basis that we need to understand for a line graph. The next is the polygraph. So under polygraph, we draw the line graphs, but they represent multiple values. So for example, we see the number of students enrolled in various schools, and we have the marking for various schools. So school C is yellow dotted line. Okay, so the values is 10,080, 1650. So these are the values that are represented for the school C, and we can see the last curve shows the school C values, and then we have the values for school A, B and C that are there on the same graph. Now when we are representing multiple lines, what is taken into account? First of all, we can represent all the 3 lines by different pattern. It could vary in terms of thickness of the line. It could vary in terms of continuity of the line. So there could be a broken line, dotted line. It could be a thick line, small line. And the benefit of this is it gives an immediate comparison. So when I say immediate comparison, what do I mean? Obviously, if I ask you which school has highest number of students, just by seeing the graph you would say obviously school A has highest number of students, and therefore as we said it gives us immediate comparison. So this school has the highest enrollment, which school has the lowest enrollment, again we can see. Now again I ask you a different question: in which year the enrollment for the school A declined but school B and C increased? So for 2016 we can see enrollment increased for school C, enrollment increased for school B, but it was only for school A that enrollment declined. And when you are doing your further researches, then you can go forward and see why did it happen in such a fashion. And the reverse phenomena occurred in 2017, where the enrollment for school C and B declined but the enrollment for school A increased, probably because they put in a lot of effort for marketing, advertisements or bringing in students, just because the fact that they witnessed a decline in the previous year where other schools witnessed an increase. So might be they improved their faculty, they improved their standard of education, they improved their co-curricular activities. There could be n number of reasons cited to it, but that's what you do actually in a research later on. You try to understand and comprehend the data, why it actually happens in such a fashion. So the next interesting graph that we talk about is a simple bar graph. So we have the test and the marks obtained by various students. Now what we do is simply we mark the marks of each of the students So on the x-axis, we take the number of the test. So the test number 1 to 10 has been mentioned on x-axis. On the y-axis, what we do is we plot the marks of the student. So when we are plotting the marks, our range is 45 to 88, which is the highest, and we see a simple curve. So we can simply say the student received the highest marks in the last test and the performance was gradually increasing in the last 4 tests. Now again, we can have the reasons why it happened. So it could be one of the reasons that since the same student is appearing for the test again and again, there is more practice that has been witnessed by the students, so better results, better outcomes. Now, some of the important things that you should take into account while doing a simple bar diagram. First, the width of each of the bars should be same. The distance between two bars should again be same. So, the distance that I am maintaining here and the distance that is maintained in each of the bar should be same. The width of each of the bar, which is this width, should again be the same width for each of the cases. And then we also say that sometimes we can make the bars much more attractive by shading or coloring, or simply we could simply draw the sketch or the outline, and if you have time you can shade it when you are drawing it actually. Okay, so that is a simple bar graph. Sometimes there is a combination of facts that are given. For example, let's say there is a combination of fact that is given for the students who are enrolled in class 10th versus the total number of students in the school. Now, if I want to plot both of these together on the same graph, what I would do is use a line and bar graph. So with the bar graph, I am explaining the number of students that are present in class 10th. And that is plotted onto the y-axis but onto the left side of the y-axis, and onto the right side of the bar axis what I do is I plot the total number of students. So this line shows me the total number of students and this curve shows me the students in class 10th. Okay, so with this value I would do a bar graph, and the class 10th students would be represented through a bar graph. The total students I am representing through a line graph. So what I am doing is I am using simultaneously a bar graph as well as a line graph in the same diagram, and this helps me solve the problem in a single chart. So my representation becomes much more simpler. Now again, when I have multiple data, I can use either a multiple bar graph or a compound bar graph. There is a little difference between the two. Under a compound bar graph, what we do is within the same bar we separate sections. Under multiple bar we draw different bars for different sections. So let's say here we are talking about a multiple bar diagram. I have the number of students as boys, girls and total students. So what I do is I plot the number of boys with pink, girls with blue and total students with green, and I have a multiple bar graph. Again the concept remains same. I have x-axis where I say the year is mentioned, y-axis where I am mentioning the number of enrollment or the number of students who are enrolling for the given school. Again, if I look onto the graph, I can see the girls' enrollment has increased for 2020. However, the number of boys enrolled for this school has significantly decreased. The scenario was not the same in 2019, where the disparity was very high between the enrollment of boys and girls for this school. So again, if you are part of the research, you can show different bases on which this categorization could be done. Another important thing to understand is multiple bar is usually used when you are trying to compare rural urban population, you are trying to compare, let's say, means of irrigation. So irrigation through tube well, irrigation through canal, or you are trying to show male female population, boys and girls in a given school or a college, the enrollments that are seen. So those are some of the places where you actually use a multiple bar diagram. Coming on to next is a compound bar diagram. Under a compound bar diagram, what we do, as we mentioned, we try to have the same height which shows the total number of enrollment, and then we divide this total number of enrollment under different streams. So let's say students in class 12th are enrolled for science, commerce and arts. Now those who are enrolled for science, commerce and arts, what would happen is, for science, let's say school A has 250 students, for commerce 190 students, and for arts 120 students. So what we do is, we draw a compound bar graph which shows the total number of enrollment of students, which is 250 plus 190 plus 120. So it is 0, 14, 6, 1. And then you have 5. So total 560 students that are enrolled in this school, and of which 250 are for sciences, 190 are for commerce, and the remaining for arts. And similarly, I plot for school B and C. Now, what happens here? I am grouping the students in one set of variable, that is the total number of students, and from that total I am segregating the streams under which the students would be there. So what I am doing is, I am simply dividing that and showing different variables through this method. The next important way is explaining through a pie diagram. Pie diagram is an interesting way of explanation because it is where it is also known as a divided circle diagram. Now this divided circle, as you can see simply from the diagram itself, it is a circle that is divided into various parts, and therefore a divided circle that is seen. Now I have, let's say, the result of the elections where 3 of the party and other candidates and the percentage of seats they have obtained. So what I do is, I need to find out what would be the area covered under the pie diagram. So what we do is, for a pie diagram, we know the complete circle is how much? It is 360 degrees. Now if 62% of the seats are won by party A, how many degrees it would be? So it would be 62 divided by 100, since it's percentage, multiplied by 360 degrees, and it gives me around 223.2 degrees, and that is what I plot. So it is 180. So if I divide this whole circle exactly into half, that is 180, I need to go beyond 180. So this whole pink region would be the region of party A, and then you would have party B, C and others that would be there, and for each of those I find out the ratio. So 21 divided by 100 into 360, which equates to around 75 degrees and so on. So this is 75.5 degrees around. So this region would be around 39 degrees and this region would be around 21 degrees. So exact values you would have to calculate, and therefore a pie diagram would be represented. Usually whenever we are representing a pie diagram, what is very important, we do not start with a bigger angle. The reason being, if I start with a bigger angle and I move towards the smaller angle, there would be a lot of error. As in this case, there is 223.2 degrees and then you would have 75.6 degrees. If I am not able to exactly locate that 0.6, 0.2, it would lead to a cumulative error, and this others would go a very small region. It would become minute, and that is because of the error that is generated. So what we do as a rule under pie diagram is, we start with the smallest angle. We first mark the smallest angle in a pie diagram, which is others, and then we move on to the bigger area, and the remaining area would be assigned to the biggest of this. Now again, this was a case where percentage was given. There could be a case where values are given. So if there is a value that is given, what I do is, I do a calculation where I find out the value of the region divided by the total value that is there, multiplied by 360 degrees, and that gives me the value for each of the sections to be represented on a pie diagram. So those are some of the basic techniques of understanding the diagrams that are there, and those, as we discussed, are the line diagrams, bar diagrams, multiple and compound bar, then we have the pie diagram, and a combination of line and bar, which is very important, where you have two y-axis that represent two different concepts, as we have already discussed. Next is the flow maps. Now flow maps are really important. Now flow maps are also called as dynamic maps. Why they are called as dynamic maps? Because they are usually represented to explain the traffic flow, the transport map, and the total transport analysis of the region, the number of vehicles passing, the number of passengers passing through a given region. So what is done is, here what we have taken is, first of all, a railway route and the number of trains going through each of the route. So let's say between Old Delhi and New Delhi there are 50 trains that run. So here we have the Old Delhi that is given, and then we have the New Delhi that is given, and there is 50 trains running between New Delhi and Old Delhi. And then we have Udyognagar to Tikri Kalan, where we have only 6 trains that are running. So Udyognagar to Tikri Kalan has only 6 trains that are running. So based on the number of trains, the number of passengers, the frequency that is there, we understand a flow map. So what we do, first of all, we go through the values, that is the number of the trains here. We find out the lowest value versus the highest value, and we try to understand the width that we would say. So let's say I select 1 centimeter as 50 trains. Okay, so then when it is 6 trains, what would be the line? It would be 1 centimeter represents 50 trains. So 1 by 50 into 6. So nearly 0.1 centimeter would be the length of this line between Tikri Kalan to Udyognagar. However, the line between New Delhi to Old Delhi would be around 1 centimeter. So the thickness of the line that was explained would vary in each of the cases. So in some regions it would be very thin, in other regions it would be very thick, that would be seen, and that shows the flow. Now to understand this flow, what we require is, first of all, a base map or a original map. With the help of base map, what we would do is, we would identify the places. So let's say I identify this is the location of Tikri Kalan, this is the location of Udyognagar, this is the location of Old Delhi, and then this is the location of New Delhi railway station. So these are the locations that I first identify. So rather than taking this whole of the map into account, I go for individual locations that are important to me, and I mark it on a separate map on same scale. Once I am done with this, I understand the number of trains that are there, and based on the number of trains, I decide the thickness. So I assume any value. So let's say for 50 trains, I assume a 5 centimeter line. So for 50 trains, if I assume a 5 centimeter line, what would be the line length for 5 trains that would be there? So it would be 5 by 50 into 5. So I would say it would be around 2 centimeters, or it would be basically half centimeter. In that case, my length of the line would be half centimeter. So if there are 10 trains, what would be the length of the line? The length of the line would be 1 centimeter. So if there are 50 trains passing through a region or that corridor, I would have a line which would be of 5 centimeters width or 5 millimeters, whatever value you take. However, if there are 5 trains passing through it, that line width would be only half centimeter. So there would be a lot of difference that would be seen in either of the cases, and that is the basis for understanding the flow maps. Now let's talk about the thematic map. The thematic maps are also known as distribution maps. Now these distribution maps, where they are important is the first question. Wherever a simple line graph, bar graph, pie graph fails to explain the detailed characteristics over a given space, we use a distribution map or a thematic map, and it gives a much more clearer picture for any concept. So let's say the first map, this shows the literacy rate in India. Now simply by visualizing this map, I can say the state of Kerala has a very high literacy rate. Now why? Because the color is very dark here and it shows above 83, and it gives me a clear picture that this is a state with very high literacy. Now on the other hand, I have the states where we have literacy rate of less than 56. So Bihar, Jharkhand are a classic example. There are of course other states with each of those, but just to cite an example. But this graphical representation if had been there either through table or through line or bar graph, it won't have been so impressive as when it is represented over the region itself. So what are the requirements first of all for drawing a thematic or a distribution map? The first is you need to have a map of the region that is there. That is the outline or the basic map that is required. It could be in the form of a physical map, it could be in the form of a political map based on the requirement that is there. So this is an example of a political map that we have taken. Now what is the rule for drawing a thematic map? The first rule is we draw the thematic map which should be a well planned map, and for a well planned map what we need is the area that should be cited properly, the name, the legend that should exist, the title that should be given, that India literacy rate is the title, north should be marked properly, then you should have a legend, you should have a scale for the map, and then a suitable method, whether it should be a method of shading, whether it should be a method of putting dots, or whether it should be a method of representing through lines. So all these methods are known by different map names. So this is a dot method. This is a method which is known as isopleth. We would understand all of these in a while. And the method where we are shading is known as choropleth. So there could be various ways for selecting a thematic map. Now thematic map can also be explained as a qualitative map versus a quantitative map. So these are an example of a qualitative map. Under a quantitative map, when we do, let's say, a rainfall depiction of less than 500, less than 50 centimeters, 50 to 100 centimeters, 100 to 200 centimeters, that is a quantitative map because we are going through the quantities. However, when we are talking about qualities, we go through either a dot map, a choropleth or a isopleth map, which are the most commonly used. So let's understand these one by one. So the first one that we would understand is a dot map. We have the total population of India. Now, we have the population that is divided for each of the state as per the census. Now, what we do is we explain the region by dot map. Dot map is classically used to show the distribution of population. So when I am showing the distribution of population, it could be population, it could be animals, it could be crops or anything. What I need to do is I need to go through the values roughly. Once I go through the values, I understand which of the values are very, very high. For example, Uttar Pradesh is significantly higher as compared to Sikkim. But Sikkim, which is the lowest value, is again in lakhs. So what I do is I divide each of these values by, let's say, 1 lakh. And what I do is I get a value of around 5.4, which equals to nearly 5 dots. Here I get a value of 1660, which represents so many dots in the region of Uttar Pradesh. So what I do is on the map of India, in the region of Sikkim, I would simply mark the 5 dots that are seen. But in the region of Uttar Pradesh, I would mark 1660 dots. Definitely a cumbersome process, but there are few rules again. All the dots should be of same size. The thickness of the dot should not vary. The consistency should remain same, and by visualizing we would be able to understand which of the regions has lesser population in contrast to other regions which have higher population that is there. So that is a basic dot map that is explained. So what we do is we go through, I repeat, the population values and we see the lowest and the highest value. Then from the lowest value we can find a number which we divide and find out a good number which could be represented as a dot. So if it is 5 lakh something, I divide it by 1 lakh, I get 5 dots, and that is good to represent. And then we find out the dots for each of the state and mark those dots on the map of India. The next is the choropleth. The choropleth maps are usually represented to show either population, literacy data, growth rate, age-sex graphs, or sex ratio that can be seen on a graph, usually from the data that we obtain from population census, are some of the good data that could be explained by choropleth map. So let's say we have the literacy rate that is given for each of the territories and each of the states that is given here. What we again do is we quickly go through the values, and we see a Kerala with a value of 90. On the other hand, we find out the lowest value, which is in Bihar, 47. I believe that's the lowest value which we have. 47 again, that's Bihar here. Okay, so we have the original values here, and we do it on a ascending order. So that's a good way of doing it. So what we do is, first we have the values for all the states. If you are using Excel, it is very easy. You can simply sort by A to Z, and you would have the literacy rate from in the ascending or the descending order. So we have arranged it in the ascending order. So we have Bihar with the lowest literacy, Kerala with the highest literacy. We take a difference of 90 minus 47. So that is around 45. So 43 is the difference that comes here. Now what happens is, I divide this 43 into categories. I want to explain it into how many categories? I want to explain it into 5 different categories. So I divide this value by 5. I take a rough value of each group would be in a set of 9. So my first value would be ranging from 47 to 56. The next value would be 56 to 65, and so on and so forth, as you can see in the values here. And above 83 would be a common group. I leave it open. Above 83, it could go up to more than 90. So Kerala, Mizoram would fall into this category. So I would shade them with the darkest color, and remaining I would shade with a lighter shade. And if there are shades that are mixing, then you can simply do it in a line fashion, or you can change the pattern under which you are doing the lowest values. Now what is the benefit? The benefit is, first of all, by assigning the shades or the colors, you are making it sure that through visual impact, the concept is well understood. What is the rule for doing a Choropleth map? When you have the concept of understanding the states that are there. So under this we have Jammu Kashmir to all the states that are represented here. We arrange them in the ascending order. We take the difference of the highest value minus the lowest value, and that highest value minus the lowest value would give me the range. Now with this range, I divide it into feasible numbers. So let's say I want to represent all the literacy in sets of 5. So I represent or group that data into set of 5, and then based on all the states that are falling into one group, I would represent them into a single section. So all these values would be represented as a single section. So my first slot would be Bihar, Jharkhand, Arunachal Pradesh and Jammu Kashmir. That would be explained in one group. Mizoram and Kerala would be explained in another group, that is above 83, and this is below 56. So that is how we divide whole of the data into groups, and then we shade the different areas in a Choropleth map. The next is the isopleths. Now isopleths are interesting. Isopleths join data with equal values. So iso means equal, pleth means lines. So I am trying to join lines of equal values. What are the common lines that we join? We have isotherms, which join the line of same temperature. We have isobar, as we can learn it as bar. So it talks about pressure, lines of equal pressure that are joined. Iso heights join the lines of equal rainfall that are there. Iso nef is the lines of equal cloudiness. How much cloudiness is there can be explained. Iso hills explain the lines of equal sunshine, the sunlight amount that is coming in. And then we also have contours, as we have understood in our various lectures, which are lines of equal height. So all these are examples of isopleth. So what we do is, under isopleth, let's say in the first diagram, we have the various values that are given. Now when we have the various values that are given, what we do is, let's say I want to draw a line of 70. So what I do is, I take the values of 67 and 77. So 70 would be somewhere in between that. But what I need to do is, I need to understand it would be 3 centimeters from here and 7 centimeters from here. Or let's say if the difference between 67 and 77, the 2 points are differing by 1 centimeter. What I do is, I take a line of 3 millimeters from here and 7 millimeters from here, and that point would be my point of 70 because I don't know the exact point of 70. So what I need to do is I need to interpolate from 56 to 77. I'll interpolate a point of 70. Similarly, 56 to 78 I'll interpolate another point. 56 to 74 I'll interpolate another point, and then 64 to 75 I'll interpolate another point. Once I interpolate all these points, I would join this as a line of 70. Now this is how we join the lines for the various values, and you can see the lines for 29, 30, 40, 50, 60, 70 and so on are joined. Now again here the rule remains the same. We draw this isopleth of the minimum value first, and then we move towards the maximum value, and that is a good way of representation of the values. Now here if you look closely, what is important, you have 75 and again 68 and here again 64. That means there would be a line of 70 and a line of 70 again. So let's say if it is talking about height, it would appear as hill going up, and then it was the height is again coming down. So this region would be a kind of highland area. That would be this region, which would be a little more in height, and then the height would get less in this region, but here it would keep on increasing. So there has to be a difference that has to be explained, and this shows a pattern which is similar to this, but here the shades change because the height keep on increasing as we move downwards. So that is how we explain a isopleth map. To summarize again, dot map, choropleth map, isopleth maps are all examples of thematic maps. They are used to explain distribution. Isopleth can be used to explain distribution of equal temperature, equal height, equal rainfall, equal cloudiness, equal sunshine, as we have understood the various names for isopleth. So this was about this. We would be bringing in many more interesting lectures for you. Stay tuned for many more updates from our side. Have a wonderful day ahead.